Okay, welcome back. Today we're going to talk about transmissions, specifically manual transmissions. Now, because this is intended for instruction, we're going to use a basic 3-speed model for this. This is an Okay, so what we have here is our 3-speed transmission now on the inside. So you can see there's a short shaft on one side and a long shaft on the other side. The short side is the input shaft, and the output shaft, it actually runs all the way through the transmission, all the way up to about that point. It's not connected directly to the input shaft. They're separate. You can see that if I have this in a neutral position, I can turn the input shaft and it doesn't transmit any power to the output shaft. You'll see on the bottom as well a shaft that's rotating, and all the gears in this particular transmission are rotating. And this transmission is what they call a constant mesh transmission, because all gears remain in contact at all times. Now, to deliver power through this specific transmission, we have special devices on here called synchronizers. And this constant mesh transmission is sometimes also called a synchromesh, because the synchronizers control the meshing of the gears to the output shaft and transfer the power there. So much like your bicycle on your transmission on your bicycle has the ability to select gears and send power through those specific gears based on where the chain aligns, this guy has a similar means of shifting it and selecting what gears it wants involved. So normally when this particular transmission runs, power travels through the input shaft up to this front gear. So this first gear that we come to is called the input drive gear. And that input drive gear is responsible for sending its power downwards. And it's going to travel into this particular set of gears. And by the way, this set of gears, and I've got an example of it, looks like this. It's out of here. All these gears are basically molded as one unit. So when this gear turns on this side one turn, all the gears turn one turn. Because everything's clustered together on one unit, it's called a cluster shaft assembly. And a cluster shaft assembly has, in this case, 4 gears on it. So the first gear is called the cluster drive gear, because that cluster gear is going to drive the cluster shaft, even though it's a driven gear. Really, it's driven by the input drive gear, cluster drive gear. So when I turn that transmission input shaft and the clutch does that job, power comes down, it travels down to the cluster drive gear from the input drive gear, and it sends it down to every single one of them. Now, no power is coming off of it yet to the output shaft. If we want to get power to the output shaft, we have to shift the synchronizers. Now, how do we shift those synchronizers? Remember we talked about a shifter. Now here's an example of a shifter on the transmission that we showed you earlier. When we basically turn the levers on the outside, there is a piece that looks like that connects a shift fork into it. And that shift fork will actually move the synchronizer collars, and that's called the collars of the synchronizer. And they will sit just like that from the side. And when I turn on the outside of the lever, or move the lever, you can see it shifting the collar forward or back based on that specific shift lever. Now, the thing is, each one shifts a different synchronizer. Now, one thing to note about these synchronizers, we can never shift a collar out of the middle position, 2 at the same time out of the middle position. There always must be one maintained in the middle position, or else the transmission will lock up. So I'm going to take this out of the way here. And you can see, by the way, before I take this out of the way, this thing has a series of little, what they call detents, spring-loaded. In this case, it's a lever. Sometimes you use notches and balls to do that, but it has the ability to shift one there or one there. Now, the neat thing about this shift mechanism is if I shift one, the other one's locked in a neutral position. So we always have to have one of the shift collars in the middle, which is called a neutral position. If we shift one forward or back, and then we select the gear. Now, let's look at the different gears in here. So it's important to know what gear is what. So if we go to the back of the transmission, these gears back here, at the very back, it's kind of handy to remember the back is actually the reverse gears. Now, reverse has actually a cluster reverse gear, an output reverse gear, and I'll turn it around so you can see it. There's also hidden behind there a reverse idler gear, and that gives it the directional change. To get reverse gear, I have to shift that collar back, so that synchronizer assembly will now lock this gear to what we call the hub assembly in the middle, and the hub assembly is what's actually splined to the output shaft. Now, because this is locked directly to that, through a series of splines in here, locked directly to the hub, it will send power directly to the output shaft. You can see that if I rotate that, you can see my output shaft wanting to turn. So now the power travels down from the input drive gear to the cluster drive gear, all the way to the back to the cluster reverse gear, through the reverse idler that you can't see right now hidden on the other side, up to the reverse gear. It locks through the collar and hub assembly to the output shaft, so it travels out. Now that's called a path of power. Look at the path of power that I'm showing you here. Do you see the shape that it has? That's reverse. And you can see me rotating, put my hand on it so you can see in the opposite direction. Now for first gear, first happens to be these gears, output first gear and cluster first gear down below. If I shift here with my synchronizer assembly, the path of power changes and no longer engages the reverse. These are idling, and this one is locked. So you can see the path of power, which is a gear reduction of about 3 to 1 in first. And by the way, reverse is similar, about 3 to 1 in the reverse direction. Path of power now goes down from the input drive gear, cluster drive gear, up to this second from the back, travels up there and out, and that is my first gear. If I want second gear on this transmission, well, this is the second gears right here, cluster second and output second. I will shift this back there. Now the path of power is going to travel downwards from the input drive gear, cluster drive gear, to cluster second, up to the output shaft second gear right here, and then travel outwards. And we have a gear reduction of about, in this particular transmission, I think it was about 1.68 to 1. Not all transmissions will have the same gear ratios for each selected gear. It's going to be specific to the transmission that you're working on. Now, you can see the change in speed right here. This guy is turning faster than the hub assembly, which is locked to the second gear, which then drives the output shaft. So you can see the gear reduction going on. If I want third gear, it's kind of interesting on these transmissions. The power actually doesn't travel down to the cluster shaft. Even though these cluster gears are all rotating, it's not being picked up by any of the other gears. Remember, this was reverse, first and second. So to get third gear, we actually will lock the hub assembly right here directly to the input shaft. Now, if we lock the hub assembly directly to the input shaft through these splines on the synchronizer assembly being lined up, we actually end up with direct drive. So when this turns one turn, so does this. It's exactly matched to the same speed, direct drive for third gear. Okay. Now, if you look a little specifically, so at these parts in here, the synchronizer parts, you can see how they work. You have what they call a blocker ring, which has got notches on it to hook the blocker ring. It's got some inserts right here. Those little floating inserts, sometimes are called dogs. And when I push on the synchronizer, what happens is, let's see if I can do that. This one has two synchronizer blocker rings because one controls a different gear. Each one controls a different gear. If I push on the collar, it pushes the brass synchronizer ring forward. The inside of the synchronizer ring itself, or the blocker ring, has a conical surface in it, or a friction surface, which is then meant to grab the conical surface on the gear that it goes up to. When it's driven forward, that smooth rotation starts creating friction. It locks them together, slows them down until they're now driving the whole hub assembly. And by doing that, when we slide the collar over, we do it without grinding. So we end up with a grindless shift. So that's the beauty of the synchronizer. It synchronizes speeds between the output shaft and the gear we're shifting, so it doesn't grind when we basically lock it together. Seamless, smooth shifting. And you can see a shift fork there before we close out today. You can see the splines on each gear that the collar assembly is locked to. And you can see all the internal structures of the transmission. Thanks for joining us today.